Alright, so step 1 to step 7 we talk about ER to relational mapping. So mean an entity relationship model. Using an entity relationship model, how we can map from an entity relationship model to the relational schema. Now the next I have couple of other steps which is going to talk about if I have a enhanced entity relationship model, then how I can map them into a relational schema. So the next few steps, step 7, I have step 8 and step 9 actually, um, that will talk about entity relationship, enhanced entity relationship model to relational mapping. So in steps 8 we are going to see how to map generalization and specialization. So we are going to convert each specialization with M subclasses. Alright, so we have a superclass S, and whether this is generalization or specialization, we know that we are going to have a superclass, and from superclass we are going to have couple of subclass. Okay, so in this method we can have actually multiple option how we can do that. So here what actually we are going to do, we are going to convert each specialization with M subclasses and generalization with superclass C. Okay, where the attributes of C, the attributes of C means the superclass, and K is the primary key. Okay, into the relational schema using one of the four option, and these of the four option we are going to use only one of the option to do the mapping. All right, so in the first option is based on multiple relations, superclass and subclass. So in this option what actually we can do, we are going to create separate relation for both superclass and subclass. Okay, so we are going to create relation L for superclass C with attributes. Okay, with attributes includes the primary key and all the common attributes. All right, and we are going to create relation for each of the subclasses. All right, so here I have the superclass G and I have two subclass S1 and S2. So that means I'm going to create a relation for superclass, and for each subclass I'm going to create separate relation. Okay, now this option works for any kind of specialization. It can be either total or partial, disjoint or overlapping. Okay, disjoint or overlapping, for any kind of specialization it works. So the superclass, the relation for superclass is going to contain all the attribute with this superclass. Okay, so A1 and the primary key of the superclass. Now for subclass we are going to include only the we are going to include only the special attribute that is specified with the subclasses. Okay, for example AS1 with S1 and this attribute with S2. Now each subclass is a as each subclass is a subclass of superclass, how we can represent that? For that we are going to have a foreign key in each of the subclass. Okay, each of the subclass that will be same as the domain of the primary key of the superclass. All right, and there will be the foreign key which will reference the primary key of the superclass. All right, so here simply for each of the class, means for each of the superclass and subclasses we are going to create separate relation. So superclass has its own primary key, but for each of the subclass we are going to have a foreign key which will be also the primary key of that subclass, and that will be also the foreign key which will reference the primary key of the superclass. Okay, from the foreign key relationship we can actually identify that this one is a subclass of a superclass. Now option B. Okay, Now second option is that without instead of having separate relation for each subclass superclass, we are going to have only relation only for the subclasses. Okay, we are going to have relation only for the subclasses. So here we are going to have relation for S1 and we are going to have relation for S2. Now all the common attributes we are going to include that for each of the subclass. For example, AG and PKG, these are the all general attribute. Okay, so each of the subclass will have a all the common attribute. Okay, now as PKG is the primary key, this is going to be the primary key for each of the subclass. Okay, so PKG will be the primary key in S1 class and this one will be the primary key of S2 class. Now we're going to include, if the subclass has any kind of special attribute, we're going to include that in each of the subclasses. For example, AS1 in S1 class and this one is in the S2 class. Okay, now option C, and let's see this one, this option B works best if the subclasses are disjoint. Okay, now option C. Option C is that a single relation for each type attribute. Okay, now whether there is subclass or superclass, for combining each of the subclass superclass, we are going to create only one relation. Okay, we are going to create only one tables. Okay, single relation with one type attribute. So we are going to create a relation, all right, that will have all the attributes. We are going to combine all the attributes here and we are going to create only one relation. Okay, so here we have primary key PKG and all the common attributes, we are going to have that, and all the special attribute also we are going to have it here. Okay, that also works only for disjoint subclass. Okay, and this works only for disjoint subclass. Okay, so remember, it works best if the subclasses are disjoint, but it only works if the relationship is, if the specialization is disjoint. Okay, now the last option is, here also we are going to create a single relation, but this will work only for overlapping subclass. Okay, all right, now if this is a overlapping, that means entities from each subclass, entities from superclass can participate in more than one subclass. Okay, now in that option we are going to actually create one relation. We are going to have all the common attributes. Okay, we are going to have all the special attributes, but we are going to additionally have some flag attribute. Okay, this flag attribute is going to denote whether a specific entity belongs to which subclass. Okay, now if there is a specific entity belongs to in both of the subclass, then here we are going to have flag 1 for both of them. Okay, so then it will identify that a specific entity belongs to both of the subclass. Now 1 0, all right, I'm just assuming that you can have a just boolean attribute type here. Okay, so 1 0, this is going to identify that this entity belongs to S1 subclass but doesn't belong to S2. Now 0 1, okay, 0 1 is going to identify that this entity belongs to only S2, doesn't belong to in S1, but this entity belongs to both S1 and S2. Okay, now let's see an example. Now in this specialization we are going to try to map this specialization in multiple option, using multiple option. Okay, so the first option, remember the first option works for any kind of specialization. Okay, in the first option we are going to create relation for each of the superclass and subclass. So let's try to map this specialization using the first option. So using the first option, we are going to create one table for superclass, one table for secretary class, one table for technician, and one table for engineer. Okay, so employee class has all the attributes and including the primary key SSN. So secretary will have only the specific attribute belongs to secretary, and it will have primary key SSN, and that will be also the foreign key that will reference the primary key of the superclass table. Same as technician, okay, SSN primary key, also foreign key, and T grade, the special attribute, and you can see for the engineer also like same. All right, so different classes, different tables for each of the superclass and subclass. All right, now let's see using option B. So if the specialization is disjoint, in that case I can also implement option B. So in this option I am going to create relation only for the subclasses. Okay, let's see how it will look. So this one, so using the option 8b, what I can do, I am going to create a separate relation only for the subclasses. So I am going to create a relation for secretary, for technician, for engineer. So I don't need any relation for employee. So secretary will have all the common attributes. Common attributes are SSN. Okay, I will have F name, M init, L name. All right, so B date, address, job type. All right, and it has a special attribute, typing speed. Okay, now technician will have also all the attributes that we have for secretary until this. Okay, these are all the common attributes, but he will have a special attribute, T grade. Okay, and engineer will have also all the attributes, and SSN will have be the primary key for all of these tables. Okay, and all the attribute here they will have, but he will have the special attribute engineer type. All right, so using the option B we can map it like that. Okay, so the relation only for the subclasses. All right, now I can also use the option 8C. Okay, the option 8C only works if the specialization is disjoint. Okay, so for the employee I have the disjoint specialization, so I can implement the option 8C. So the third option means that I can create only a single relation. Okay, I can create only a single relation, so I am going to create a single relation. So these are the attributes, all the general attributes. Then I am going to include all the special attribute also. So typing speed is for secretary, I believe. So T grade is for technician, engineer type is for engineer. Okay, now if a entity is a technician, okay, if entity is a technician, in that case the attribute value for typing speed and the engineer type will be null. Okay, so means if I create a single relation I have to allow null value for each of these attribute. Okay, so the technician will have a value for T grade, but he will not have any value for typing speed or engineer type. Okay, as the same, like if a employee is an engineer, so for an engineer the typing speed will be null, the T grade will be null, and engineer will have a special engineer type will have a specific value. All right, Now as this is a disjoint specialization, I cannot implement the last option, option 80. Okay, it only works for overlapping. Now I have a specialization, overlapping specialization. Here I have part. All right, now the same part can be both manufactured part and purchased part, so that's why it's a overlapping and it's a total participation. Okay, all right. So this mapping I can use here. There is an example here. I can use I'm doing using 8b. All right, this mapping is done using 8b. All right, means single relation for each of the only subclasses. Okay, relation only for the subclasses. So I am having a class for, so this mapping is from the specialization from the car. Okay, so here we have an example of specialization where the general class is the vehicle and special class are car and truck. Okay, so you can see that this is a disjoint. This is a disjoint. Okay, now using the option 8b, we can actually create a multiple relation for only for each of the subclasses. So there I will have subclass for car and for truck. Okay, so and you can see that I will have all the common attribute like vehicle id, price, license plate. Okay, so these are the all common attribute. Okay, now max speed and number of passenger belongs to only car, and number of aisle and tonnage is only belongs to truck. Okay, so this is the example where we are doing the mapping from the part specialization here using this one, and this one is an overlapping attribute. So and we are implementing the last option like 8d, where we are going to do a single relation. But if we do the single relation and as this is the overlapping, we are going to include all the attributes, but also we are going to specially include a flag attribute for each of the subclass. For example, if the entity belongs to manufactured part, the M flag will be 1, and if the entity belongs to purchased part, the P flag will be 1. Okay,